In this lecture, we will see propagation of TM waves in rectangular waveguide. In last lecture, we saw about propagation of waves in rectangular waveguide. Here, particularly, we also derived wave equations for TM wave and TE wave. Based on the TM wave, we have to see that propagation of TM waves in rectangular waveguide. Here, for TM wave, Hz is equal to 0 and Ez is not equal to 0. That means in TM waves, Hz component is present and Hz component is not present in TM wave and Ez component is present in TM wave. So that's why Ez is not equal to 0, Hz is equal to 0. Here the wave equation for TM wave is dou square Ez by dou x square plus dou square Ez by dou y square plus h square Ez is equal to 0. Here we already saw about how we get this expression for TM wave in rectangular waveguide in last lecture. So based on the wave equation for TM wave, we can analyze the propagation of TM waves in rectangular waveguide. Here consider this equation as first equation and the above equation is partial differential equation. Now we observe that the above equation is partial differentiation equation. So let us assume the solution is Ez is equal to xy. Let us consider Ez is equal to capital X capital Y. Then consider this equation as second equation. Then where x is purely function of small x only and capital Y is purely function of small y only. So and x is dependent variable and small x is independent variable. Similarly, capital Y is dependent variable and small y is independent variable. Here capital X is a dependent variable and small x is independent variable and capital Y is dependent variable, small y is independent variable. And then next, by substituting equation 2 in equation 1, equation 2 is Ez is equal to xy. By substituting 2 in 1, that means here in the place of Ez we are replacing Ez with xy. So by substituting equation 2 in equation 1, now we get dou square Ez by dou x square is equal to dou square Ez. In the place of Ez we can kept xy, we can substitute xy. So dou square of xy by dou x square is equal to, so here we are derivating with dou square of xy with respect to x. So here the derivation of dou square by dou x square into xy is equal to y of dou square x by dou x square, because here we are derivating with respect to x. So here y is a constant. So y dou square x by dou x square, consider this one as third equation. And another one is dou square Ez by dou y square. This is second element. Dou square Ez by dou y square is equal to dou square x by dou y square. Here we are derivating with respect to y. So here x becomes constant. So x dou square y by dou y square, consider this one as fourth equation. And by substituting equation 2, 3, 4 in 1. Here equation 2 is Ez is equal to xy and equation 3 is y dou square x by dou x square and equation 4 is dou square Ez by dou y square is equal to x square x d square y by dy square. Here by substituting equation 2, equation 3 and equation 4 in 1, then we get, here by substituting equation 2, equation 3, equation 4 in equation 1, then we get y dou square x by dou x square plus x dou square y by dou y square plus h square xy. Here in the place of Ez we are replacing with Ez with xy and dou square Ez by dou x square in the place of dou square Ez by dou x square, we are writing dou square x by dou x square, y dou square x by dou x square. So y by xy, dou square x by dou x square plus x by xy, x dou square y by dou y square plus h square xy is equal to 0. Consider this equation as fifth equation. Now divide xy in equation 5 on both sides. So here divide xy in equation 5. This is equation 5. Divide with xy on both sides. Then we get y by xy dou square x by dou x square plus x by xy dou square y by dou y square plus h square x by y xy is equal to 0. Then we get here y is cancelled, then 1 by x dou square x by dou x square plus here x will cancel, then 1 by y dou square y by dou y square plus xy will cancel, then h square is equal to 0. Consider this equation as sixth equation. Now here it is a purely function of x only and it is a purely function of y only. So consider this equation as sixth equation. And now therefore the sum of above two terms is constant. So let consider 1 by x dou square x by dou x square is equal to minus b square. Consider this one as seventh equation. And now 1 by y dou square y by dou y square is equal to minus a square. Consider this one as eighth equation. So now equation 7 and equation 8 are second order partial differential equations. Then the solution of which are given as x equal to capital X is equal to c1 cos bx plus c2 sin bx. Consider this one as ninth equation and capital Y is equal to c3 cos ay plus c4 sin ay. Consider this one as 10th equation and here c1 c2 c3 c1 c2 c3 c4 are constants. To get these constant values by using boundary conditions. So here by using boundary conditions we have to find that c1 c2 c3 c4 values. So by substituting 7 and 8 in 6, here the 7 and 8, these are the 7 and 8 equations, and the sixth equation is here. The sixth equation is this one. So here now we have to substitute 7 and 8 equation in this sixth equation. Then we get minus b square minus a square plus h square is equal to 0. And now h square is equal to a square plus b square. Consider this one as 11th equation. Therefore by substituting 9 and 10 in equation 2, then Ez is equal to xy. So here Ez is equal to xy, we find that x as c1 cos bx plus c2 sin bx and y is c3 cos ay plus c4 sin ay. So this is the last final Ez component expression. Now we have to find that by using boundary conditions we also find that hx, hy, ex, ey, ey